everyone. In today's lesson, we're going to talk about the last day of area between curves. So I want to find the area between this line, 7x, and this cubic function, x to the third minus 9x. And I want to find the area between them. And what you should be noticing from this picture right here is that there is an area here, and there's an area here. So what we're going to have to do in a case like this where the areas are separated, we're going to actually have to separate the two integrations. So in this one, we have a top and a bottom. In this one, my curve is my top and my line is my bottom. In this one, my line is my top and my curve is my bottom. So that's why we really can't use the same equation for both parts. So we can see here that this happens from -4 to 0. So the first one goes from -4 to 0. And then the second one is going to go from 0 to, it looks like over here, from 0 to 4. So the top in my first one, like I said, is my curve. So the top is x to the third minus 9x. That's the curve minus the line, dx. The next one, my top one is my line and my bottom one is my curve. So the 7x minus x to the third minus 9x dx. And that's how you would calculate them. And we'd add them together to find the total area. So I'm just going to simplify this here. So distribute this. So x to the third minus 9x minus 7x. That becomes x to the third minus 16x over the interval from -4 to 0 dx. And then this one, I'll just distribute this. So we have 7x minus x to the third plus 9x. So this would be the area here from 0 to 4. So take a couple minutes and plug this one into the calculator and this one into the calculator and hit resume when you're ready for the answer. Okay, so for the first one, I got 64. And for the second one, I got 64 as well. So if we take this 64 and add it to this 64, we get 128. And this is my final area. All right, so let's try another example. What I'd like you to do now is graph these two equations on the XY axis and draw a sketch, and then hit resume for the explanation. Okay, so here's my sketch. And if you look at the first glance, you're going to see that because of this positive 10 up here, that means the graph is going to intersect up here at 10. And this -10 means that this graph is going to intersect down here at -10. So it's a little hard to see. So before you do anything, I'd actually like you to go to your window. So please hit window on your calculator and change your y max to equal 100. This way you're going to get a general idea of what the graph looks like because you really can't see it at first glance. So if I were to draw a sketch, a better sketch, maybe without the XY axis, you know, so much, well, maybe we'll call this, you know, if this is 10 and then this one's -10, the idea is the graph kind of goes like this and then up, right? That's your cubic. That's this one right here. And maybe I'll change colors. I'll do the red one for this guy. If you do the x to the third minus 10, or sorry, x squared, this guy, it kind of looks something like this. And it's very hard to see, so you really kind of have to play with the window. But the idea is that this thing is actually intersecting, and when I'm finding the area, we've got this area in here and this small area in here. So I'm really trying to find this intersection point and this intersection point and this intersection point. So there's really the area between the curve is, there's two spots here. And how we can prove that if we did it algebraically, I'll do the algebra over here. We have x to the third minus 2x squared plus 10 equals 3x squared plus 4x minus 10. So I'm going to set it equal to 0, factor and solve. If you want to try this on your own, pause the video. If you want the explanation, keep listening. So I'll subtract the 3x squared, I'll add the 10, and I'll subtract the 4x. I'll just put that somewhere over here. So I have x to the third minus 5x squared minus 4x plus 20. And what you're going to notice is that this type of factoring has 4 terms, and if you remember, that's factor by grouping. So we're going to group these first 2 terms, bring down the minus, and group these second 2 terms. So we take out a GCF of x squared, and we're left with x minus 5. The last 2 terms, we take a GCF out of 4, and we're left with x minus 5 again. And remember, these 2 are the GCFs, so they get their own parenthesis followed by these 2. So it's x minus 5, and then x squared minus 4. And the x squared minus 4 is dots, so that'll give us x plus 2, x minus 2. For solutions of 5, negative 2, and 2. So this x value is negative 2, this x value is 2, and this x value is 5. So those are the spots where we're going to break up our integration. And we have to figure out what's on top and what's on the bottom. So in this particular spot, this section, this is obviously my top, and this is obviously the bottom. And now here the line is my top, and the curve is my bottom. So we're going to break up the integration into 2 parts. So if I were to write it out, we're going to say the integration from negative 2 to 2 would represent this area. The top is the curve, the x to the third, and the bottom is the x squared. So the x to the third minus 2x squared plus 10 minus the x squared, so 3x squared plus 4x minus 10, and then dx. That's the first piece. And then we're going to add it to the integration of 2 to 5, but the top is now the line. So the top is, not the line, excuse me, the curve, the x squared. So 3x squared plus 4x plus 10 minus x to the third minus 2x squared plus 10 dx over the interval from 2 to 5. So you can take a couple minutes and simplify those. Just for purposes of space, I'm not going to show how to do all that. So take a minute, simplify them, put them in the calculator, and then hit resume when you're ready for the answers. Okay, so for the first one, I got 53.3 repeated. And for the second one, I got 24.75. And the directions say to round to the nearest thousandth, so that's 3 decimal places. So we'll make this 0, and I'll make this 333. And we're going to add these 2 together, and we'll get the final answer. So add them, and your answer should be 78.083 units squared. That should be your final area. All right, so just to recap this one, because I know it's a little bit tricky, because of this y-intercept of 10, it was very difficult to see how the entire graph looked. So it's really important that if you wanted to see more up top, you want to see more of the y-axis, you have to change your y max by going to the window to get a 100 or a very large number to see the behavior for the rest of the graph. And if you want to get your calculator back to your regular window, you have to hit zoom 6. So I'll put that over here. Zoom 6 says standard. That will bring you back to your original graph of a 10 by 10 on both sides. Okay. If you have any questions, please let me know. I know this one was a little bit trickier. But other than that, that's it for today. Have a good one.